Okay, we have to evaluate this integral of x minus 1 divided by x plus 1 into square root of x cubed plus x squared plus x dx. Now, under this root, there is an x cubed plus x squared plus x, and that's a expression that we're not normally encountering. Yeah. So this is the one that's going to guide what we're thinking. If we have x cubed plus x squared plus x, I can probably take an x out common, and then I have an x squared plus x plus 1 there. But then I have a root x outside, which is really problematic. Yeah, I don't know how to deal with two surd expressions. So what we do here is we're saying, okay, when we've encountered stuff like this before, expressions like this, we could take an x squared out. If we take an x squared out, then this expression will just reduce to x plus 1 by x. And this x plus 1 by x is a very commonly occurring expression. But when we've taken the x squared out, it has just become an x. It's just become an x. So I have x plus 1 into x root x plus 1 by x. Now I'm thinking about making a substitution x plus 1 by x equals my new variable. But in order to do that, I need to have 1 minus 1 by x squared dx in the numerator so that I can readily substitute that as the differential of my new variable. But now if I look at 1 minus 1 by x squared, there the powers, yeah, 1 is x to the power 0 and 1 by x squared is x to the power minus 2, and so there's a difference of 2 in the powers, whereas here right now we have a difference only of 1. So what we could do is multiply the numerator and the denominator by x plus 1. That will give us an x squared minus 1 here in the numerator, x plus 1 whole squared in the denominator. And then now, if I divide by x squared, the numerator and the denominator, I will get an expression that I can deal with. So let's see what we have. So multiplying numerator and denominator by x plus 1, we get x squared minus 1 divided by x plus 1 whole squared into root of x cubed plus x squared plus x dx. Now remember, we're going to take an x squared out here from this square root sign, and so that will become an x in the denominator, and then I divide the whole numerator and denominator by x squared. So I have 1 minus 1 by x squared. This expression, when I expand, would have become x squared plus 2x plus 1, which if I divide by x gives me x plus 2 plus 1 by x. And the remaining x also, which was out there, gets cancelled. Under the root sign I have x plus 1 plus 1 by x. So moving things around, I have 1 minus 1 by x squared divided by x plus 1 by x plus 2 into root of x plus 1 by x plus 1. So now I make the substitution, x plus 1 by x plus 1 is t squared. So this entire thing under the square root sign is t squared. So with the square root sign it will become t only. So I get rid of my third expression that way. So automatically I have 1 minus 1 by x squared dx equals 2t dt. Plugging that in, I get 1 divided by t squared plus 1 root t squared into 2t dt. The 2 can be taken out. The t and the root t squared cancel. What is remaining is integral dt by 1 plus t squared, which is the standard form. That is 2 in tan inverse t. And plugging in the value of t, x plus 1 by x plus 1, the square root of that, I get the integral to be 2 tan inverse square root of x plus 1 by x plus 1 plus c.